Welcome to the Slop Temple. We pray this video helps.
You start by confirming the battery type and polarity so you avoid reverse connections. This matters because wrong polarity can destroy electronics. Once done, visually inspect the connector pins and housing, looking for corrosion, bent pins, or frayed insulation. Next, prepare your tools: an accurate multimeter, insulated pliers, proper crimps, and heat shrink tubing. Make the first physical connection to the battery's negative terminal briefly to verify fit and clearance. Keep your hands clear of live positive contacts. You now focus on making the electrical connection reliable. Strip about 5 to 7 mm of insulation, twist the conductor and insert fully into the crimp barrel. Avoid nicking strands because that reduces strength. Once positioned, crimp with the correct die until you see the crimp marks. This ensures consistent resistance. If the manufacturer allows, add a small solder fillet to prevent stray strands, and then apply dielectric grease and heat shrink for insulation. Finally, route and secure the cable to prevent flex and chafing. You finish by performing functional checks that validate safety and performance. First, measure open circuit voltage and continuity across the connector to confirm correct polarity and low resistance. Once done, apply a brief test load while watching for heat, smell, or arcing. Any abnormal sign means stop and disconnect immediately. If something goes wrong, make sure to recheck crimp quality, pin seating, and connector orientation, then replace any damaged terminals. Remember, a secure mechanical crimp prevents most intermittent failures. Repair, don't guess.
Thanks for watching. Consider subscribing if we helped you.